Alright guys, welcome back. Today's video is going to be on the basics of percent composition. Okay, percent composition is going to be broken into two videos. The first one is on the basics of percent composition. The second one is on using percent composition to determine the purity of a sample. So figuring out how much impurities or error essentially is in the sample size. Okay, so the basics of percent composition. We did this a lot in honors chemistry as well as in regular chemistry, so hopefully everyone has a pretty good idea of percent composition. Let's just jump straight into a problem. I think that's the best way to explain it. So I'm just going to do a little example here. It's what percentage of H2O is hydrogen and oxygen? Okay, so what percentage of H2O is hydrogen and oxygen? Okay, so the steps. Alright, so step one. The first thing we're going to do is find the molar masses. Find molar masses, okay? Now I need to do this for every element in my compound. Since I'm dealing with water and it's just hydrogen and oxygen, I just need to find the two of them. Okay, so I know hydrogen has a molar mass of 1 gram per mole. And I know oxygen has a molar mass of 16 grams per mole. Okay, so you just look those up on the periodic table. I rounded to the nearest whole number because they're like 1.0001 or something like that. It's really important to realize that since I have two hydrogens, the total mass of hydrogen in the compound is going to be 2. Okay, because I have two of them. So it's H2O. So I need to multiply by 2 to say how many grams of hydrogen are present. Okay, so it's H2O, so I need to multiply by that 2. So I have 2 grams per mole, or 2 grams, essentially, and here I have 16. Okay, so step 2, divide mass by total mass O compound. So I'm going to take the mass of these and I'm going to divide it by the total mass to figure out what percentage of the total mass are the elements, right? Percent composition, the percentage of the mass. So the total mass, 2 plus 16 is 18. So to find out what percentage of this compound is hydrogen, I'm going to do 2 divided by 18. So hydrogen is going to be 2 divided by 18. And oxygen is going to be 16 divided by 18. So how much of this total 18 is hydrogen, and what percentage of this total 18 is oxygen? Okay. And then through the magic of already doing it on my calculator, I know that it's 11% and 89%. So I know that 11% of water is hydrogen. And I know that 89% of water is oxygen. Okay? Okie dokie. Now let's say, what if you're given the percentages? Alright, this is pretty straightforward. This is like regular chemistry math, right? With a little practice, we can get up there. We can handle this. We're just finding percentages. What if instead of me saying, what's the percentage, what if I give you the percentage? Now that's a little bit trickier. So let's do a different example. Let's say a sample of CX and HY. So I know it's made up of carbon and hydrogen, but I don't know how many of each. That's why we've used the variables X and Y. CX and HY. So I have some hydrocarbon, some compound with just carbon and hydrogen, but I don't know how many of each there are. So, but it has 92.3% carbon, and obviously then 7.7, put a little line there to make that, percent hydrogen. Okay? What's the formula? Okay, so I say I have a hydrocarbon. It is CX and HY. It is 92.3% carbon. It is 7.7% hydrogen. Excuse me. I want to know what the formula is if the molar mass of that compound is 78 grams per mole. Now, this is actually a fairly common or everyday chemical problem. There are machines, mass spectrometers, will pump out answers in percentages. So you have this unknown liquid and you pour it in, and it will say, unknown liquid is 92.3% carbon and 7.7% hydrogen. It doesn't talk, just so you know. That was just for your benefit. It actually just prints it up. It's probably just on a computer screen now. Don't look behind the curtain. Alrighty, so the steps. The steps to that. Alright, the first thing we're going to do. Assume a 100 gram sample. Okay? Assume a 100 gram sample. And we're going to do that because it makes math easy. That's why we do anything, to make the math easy. So if I have a 100 gram sample, therefore, and I'm going to show you something really cool, a therefore sign is a triangle of dots. That means therefore. So assume 100 gram sample, therefore I would have 92.3 grams of carbon, right? If 92.3% of a 100 gram sample is carbon, well, that's 92.3 grams, right? If 92% of 100 is 92. If you get a 92 on a test, you got a 92%. If the test was out of 100, right? And whoever doesn't make tests out of 100 is crazy. Also, I'm going to have 7.7 grams of hydrogen. So I have 92.3 grams of carbon and 7.7 grams of hydrogen. Put those hash lines in there just so it's clear that those are 7. Okay, step 2. Step 2, now that I have grams, well, I'm looking for grams per mole, or I'm looking for a number of atoms. Oh no. If I have grams, I need to convert that into moles, because moles is what we use as a measurement in chemistry. So I have to take my grams and I have to turn it into moles. So to do that, I divide by molar mass. So I take that and I divide by the molar mass. So if I say I have 92.3 grams divided by the molar mass of carbon, which is 12 grams per mole, that's going to give me quite possibly exactly 7.69 moles of carbon. At the same time, if I have 7.7 grams, I divide that by the molar mass of hydrogen, that's 1 gram per mole. That's going to give me, you might have guessed it, 7.7 moles of hydrogen. Okay, it's going to give me 7.7 moles of hydrogen. So, let me erase this because I'm running out of room. Or rather, I don't want to bend over because that's just weird. Yeah, I'll erase the prompt. Hopefully you wrote down the question because you're going to have some necessary information. Okay, let me rewrite these numbers, 7.69 and 7.7. So I have 7.69 moles of carbon and 7.7 moles of hydrogen. Now you'll notice I want a ratio. So my step 3, and in this case it's pretty simple to see this, but in step 3 I divide all numbers by the smallest one to get a ratio. So I want a ratio of this many carbon to this many hydrogen. So I'm going to divide both by the smallest number. Now it turns out that these numbers are essentially the same, right? 7.69 and 7.7 are essentially the same number. So my ratio is going to be 1 to 1. That's my ratio. So for every 1 carbon, I'm going to have 1 hydrogen. For every 1 carbon, I'm going to have 1 hydrogen. So our compound is like CH. All right, C1, H1, one of each. Okay. Now, the little part in the prompt that's important that I erased was that the molar mass of this was 78 grams per mole. That was the molar mass of the compound. All right, so I know it has some equal combination of carbons and hydrogens, and that equal combination has to add up to 78. Okay? So, here's step 4. You know what? I can just keep this. I can write it down below. All right, step 4. Divide molar mass. I'm going to say divide, whoops. Not molar mass. Divide ratio mass by molar mass. So if my compound is CH, I know that carbon weighs 12 and hydrogen weighs 1, so the mass of this thing is 13 grams, right? So carbon 1, hydrogen 1 weighs 13 grams. And I know that some variable of that or some amount of that will eventually weigh 78. So the way I do this is I do 78 divided by 13. What am I doing? 78 divided by 13. And that gives me 6, right? Okay, so I guess I said that right the first way. Anyway, so I take my molar mass of my compound and I divide it by my ratio mass. So I set it backwards here. Let me flip this. So I take 78 and divide by 13, that gives me 6. And that tells me my subscript. So I know it is C6H6. Because C6H6 is essentially a 1-to-1 ratio of carbon to hydrogen, so that's true. And it also weighs 78 grams total, because 6 times 12 is 72. 6 times 12, the molar mass of carbon is 72. Plus 6, which is the molar mass of 6 hydrogens, 72 plus 6 is 78. Okay, so it both has the 1-to-1 ratio and the appropriate molar mass. Okay, now I know I kind of flew through that, and I promise you we'll do some more activities in class on that all later. All right, well that was video number 2. All right, you know what? Actually, before we go, I'm going to put up a problem that I would like you to solve. I am not going to give you the answer, but we'll go over it in class. Okay, so you have to do this before you come to class. You have to do this before you come to class because this is a problem. So please solve. What is the formula of a compound with 85.7% carbon, 14.3% hydrogen, and a molar mass of 84 grams. Okay, so what is the formula of a compound if it has 85.7% carbon, 14.3% hydrogen, and a molar mass of 84 grams? So you have to do exactly what we just did for this problem, and I will give you the answer in class. Okay? Have a wonderful day, and good luck with your percent composition problem. Bye.